right, let's get started. Welcome everybody to OpenCV Live. And today we have with us one of our favorite guests, Paula Ramos from Intel. She's an AI evangelist at Intel, and joining her is Samet Akcay, who is a tech lead at Intel. And they are going to talk about Anomalib, which is a library for anomaly detection, and it's gaining a lot of traction. So we are going to have fun learning about it. It is going to be a new thing for me as well, because I have not gone through and tested or checked out Anomalib. So I'm very excited to learn something new today. And as always, with us is Phil Nelson, who is the Director of Content and Creative at OpenCV. He organizes the show, and if anything goes wrong, it is his fault.
He's absolutely right, folks. And today we are here for a good time, not a long time. On this 1 hour episode, we will get a presentation from our esteemed guests, as well as taking questions from you in the audience. I am your co-host with the co-most, the second banana who is second to none. I'm also your +1 and only. It's Mr. Nelson, if you're nasty, but you can call me Phil. And on this show, we take your questions, we try to answer them. We'll also give something away to you in the audience. Stay tuned. Later in the episode, I will be asking a trivia question based on the presentation from our guests. And if you answer that question correctly, you will win the OpenCV course of your choosing. You can go to opencv.org/university to see what courses are on offer right now. Stay tuned for that. That is all I got for right now. Satya.
Well, we were going to address Phil as Mr. Nelson in our NSF proposal, but he objected to it.
I was trying to figure out a way to get a Janet Jackson reference in the grant proposal, but I don't know how cool the reviewers are.
All right. So welcome, Paula and Samet. We are very excited to have you here. It's your show now. Very excited to learn about Anomalib.
We are so excited to be here. So thank you for having us. Our last time together was in CVPR, if I'm not wrong.
Yes.
We have a lot of fun there with our networking session that we made, and we shared the space with the networking. And I hope that today will be the same. No, just fun.
That was
I just want to thank Intel for doing that, because Intel gave us a space in their party. They were organizing a party, and they gave us a space with no strings attached, right? They didn't say that, oh, you have to promote Intel or Intel processors or anything like that. They just said, have the space and do something cool, right? And so we did a demo of generative AI, a postcard demo. So it was really fun. Thank you so much, Paula.
That was a pleasure to have you there.
Yeah, and those cocktails were strong, let me tell you.
And the food was good also, no?
Absolutely. That was a killer party.
Okay, now let's move to a serious way. So let me introduce myself first. Can you see my screen?
Yes.
Okay, perfect. Paula Ramos, originally from Colombia. I'm living in the US, in the East Coast. I have a PhD in engineering, and I have more than 18 years of experience. My passions are all related with artificial intelligence. In the past, I was working in agriculture, 14 years in agriculture. And I joined at Intel because of you guys, because of OpenCV, because I was participating in a competition, and that competition opened the doors to my career.
You were part of a winning team, yeah, and you were leading that team.
Yes, I was in the first competition, in the second competition, and I'm glad that you right now also have a competition ongoing.
Yes.
Yes, please go to hackster.io for OpenCV AI Competition 2023. The preliminary phase is over, but you can still join and participate. You'll just be starting a little bit later than everybody else, but that doesn't mean you can't win. It's still free. We've just passed 1,200 signups, so get in there and maybe win your share of the over $40,000 of cash and prizes.
That is amazing, as usual. So I just finalized my introduction, so Samet, go ahead.
All right. Yeah, I'm Samet. As I just mentioned at the beginning of the call, I'm from Durham, UK. The reason why I'm here is because I started my PhD here at Durham University and finished in computer science. But before that, I used to live in the United States. Went to my I was in State College, Pennsylvania for my master's degree. I went to Penn State. So almost 8 years, more than 8 years of experience for a researcher. But I'm glad to be here because, when I first started working on, computer vision problems, I started with OpenCV. And back in the day, I could, I wouldn't imagine that, I would be invited to an OpenCV webinar. That's right. Really impressive.
We all started with OpenCV.
Thank you.
I used it in grad as well.
We are so glad to have you, Samet.
Thank you. I guess that's about it from my side. Paula, we can start, right? So
yeah,
you can go ahead.
Yes, for sure. I was muted, sorry. So today we will talk about different things. So we'll talk about Anomaly. We are so excited about the story that we have with Anomaly. And Samet is one of the owners of this team. And we will have also this, technical approach about Anomaly. But we need to be sure about that also we are covering the use case. So we need to think about what is the challenge that we have in defect detection. So why we need to use Anomaly and what Anomaly is. And how also OpenVINO is working with Anomaly. We will show you how you can get started with this use case and what is next in this journey that developers are looking for new technologies or new examples or new cases to study. So let's start with the challenge. So I think that we need to think about that defect detection. In defect detection, we have a lot of challenges. And basically here, I think that is so simple to understand in this slide, where we can see the defects on these chips. We can see maybe we have 2 defects in 6 images and 4 normal images. But when we increase the number of data, that will be difficult to identify where the defects are. So I want to ask you, Phil, where do you see the defects here? How many defects did you see here?
Let me engage my robot vision.
Okay, let's see.
Bottom right quadrant. I don't know.
Okay, so we can see maybe one defect here that is clear.
Yeah.
But we see another ones, no? Satya, what do you see? What do you see?
Yeah,
here?
so in that row, there are two defects, at least, right? In that row.
Third from the left and 1 down.
In the
Fourth from the right and 1 down.
That one.
Mm-hmm.
Third from the left and 2 up. That's all I can see easily. Yes.
Okay, so
you're gonna tell me they're all defective.
You are totally right. You are a good computer vision man.
I'll just run Anomalib.
Okay, this is your take. Okay, this is good. So the point here is it's difficult if you increase the number, and normally it's also difficult to understand how these defects are coming in the industry. So as you were working on that. I know developers that are connected right now are working on supervised learning that maybe is easier to train something, but in this case, we don't have the proper data sets. And I think that also this is important to understand the challenges that we have with imbalanced data sets, because we have a lot of good information and we don't have enough defects to create this supervised information. I don't know, maybe I'm missing something, Samet, so could you complement my idea?
So we can definitely train a supervised model that can achieve quite high performance. But the problem is, as Paula pointed out, so the nature of defect is unknown. So the next day we can have another type of defect which we never seen before. Yeah. And then in this case, the model that we trained is probably useless and it's not gonna work anymore. So we need to retrain the model to have that sort of defect as well, and this will continue. So that's the problem with the supervised nature of the training.
Yeah, and
can I ask a quick question? What kind of chip is that?
It's a secret.
I see. Top secret chips, only on OpenCV Live, folks.
So one of the things that I wanted to point out is that this kind of problem is prevalent. It's there everywhere. Like even in our consulting work, we have solved problems for like let's say handbag, detecting fraud in handbags, right? Because these high-end handbags, some of which sell for a few $1,000s, they there's a lot of fraud, right, in this area, because there is such a big margin there, and people want to capitalize on that, like the fraudsters. So, but the problem is that first of all, they are very good at this, and so the defects or the fraud examples would be very close to the original, and there are only a few of them, right? Even if you're a shop selling this thing, you would find 50 out of thousands and thousands of examples. So very few negative samples, or very few defective samples. And same thing happens with fraud detection. When you do ID fraud, and you're trying to detect, oh, the fraudster, and once you fix that, right, let's say you train a model and the fraudster is not able to pass through, they're going to change, right? And the same thing happens in this case also. Let's say you're finding a defect again and again, and you find the root cause, then Intel is probably going to fix its process, right, whatever process they use. And now that defect is no longer happening. New kinds of defects are happening, right? So it's a moving target all the time, and that is why it is difficult to solve it in a supervised manner.
Yes, and also imagine the cost that a factory could have if you find a new defect and you need to retrain the model. So how many of those defects are right now in the normal data? So this is a big deal.
Yeah.
So, but we are here not just to talk about the problem. So we want to talk about the solution.
Right.
So, and this is also why we are here. Samet is here, because we are so excited to talk about Anomaly. Anomaly is an end-to-end library to design, implement, and deploy unsupervised anomaly detection models. So, Samet, could you define in just a few words what Anomaly made for developers?
Yeah, of course. Before I start talking about Anomalib, maybe when are we going to talk about how it was born, or like that sort of stuff, or should we talk about that as well?
This is great, yes.
Because I think it's kind of related to the previous slide. During my PhD, I was working on this sort of problems. So in different contexts, not just defect detection, but threat detection and other sort of problems as well. And I was basically using supervised models initially, right? And then when these were like external customers. So when we were going to them and then showing the product, and then they say, okay, yeah, this is working really good for this. But, how about when we have this sort of problem in the future? Yeah, oh yeah, we can train our model again. Yeah, that's fine. It's because the fine tuning doesn't, take quite a long time. But they say, we can have this problem every single day, maybe like multiple times a day. And then we just found out at the time that, okay, we need to, change our approach here, because, the supervised models won't work here. Because they were telling me that, the objects of interest could be anything. So we don't know. What they know is the normality. But in regards to the abnormality, they don't know. It could be anything, right?
Right.
So we said, okay, yeah, in this case, maybe we should just start learning just the normality, what the normal should look like. And this is how we started working on the anomaly detection problem, because this is what the anomaly detection problem is, right? So you learn the normality, and then based on what you learn, we just trying to find out the abnormality. So it's kind of one class problem in deep learning terminology. So, and then this is how it was initially. We started working on it during my PhD days. And then maybe we can just start talking about Anomalib. Yeah, so back in the days, I was pretty much starting from scratch. So, I was trying to use some existing codes to reproduce the experiments. For supervised models, there are tons of libraries out there. People can just easily reproduce experiments, run some new models and stuff. But for anomaly detection, it was not possible. And at the time, I was kind of alone and just writing everything from scratch myself. So it was super hard. And then once we had a chance to work with Intel and then had a small team of 3, then we said, okay, we're working on this anomaly detection, and why not just create a library? Because, you know, the literature is already missing this. And then if we just, and we know what's missing in the literature, and we know we spend so much time on this, you know, code writing process and stuff like that. So why not just produce a library so that, you know, other people can benefit, so that they don't need to, you know, reinvent the wheel. So the things that we did during our PhDs or master degrees. And then this is how we decided to create this library. And we tried to make it as simple as possible because, you know, I knew the challenges I faced during my, you know, research phase in a master's and PhD, you know, all the simple things, which took us days to fix actually. So we said, okay, it should be like as simple as possible so that anyone can just get up to speed so quickly so that they can just run their experiments. So like we always thought the simplicity in mind and then built this library. And yeah, it just got huge attention from the open source community.
And this is also great, you know, that this is open source.
Yeah.
I mean, developers can use this one. They can find the state of the art of the algorithms that the you know, the Anomaly community is working with. And I think that is a cutting edge in anomaly detection, because we can find in one single place a lot of algorithms for different kind of use cases. So it's fascinating. So let's continue. So here we have some examples. You know, we can see what kind of things is happening when we have the normal information and what kind of things happen when we have the defects information. And, you know, I'm working with this robot. I'm also recreating the use case for, you know, showing this to different developers so they can replicate the work that we are doing. And this specific defect detection is, you know, working with this robot. So if anybody in the audience or, you know, they already have this robot, they can also replicate the work. We have all the codes to manage, control the robot, and also run Anomaly in a simple way, because Anomaly is easy to use. So, but I want to explain you how this is working and the foundation for this. So any questions so far, Phil?
What kind of robot? What's the name of the robot, if you don't mind me asking?
Yes, this is a robot magician. It's an educational robot. So, and they have the complete package. So they have I have the robot here for the next demo that I need to do. So
this was the same demo you were doing last time we saw you at CVPR, wasn't it?
Exactly. In that time, I was running Anomaly there, but I have the robot here. I have also the conveyor belt. I can put different kind of objects on the conveyor belt. For this, you know, kind of demonstration, I'm using cubes, but also I can use, you know, blisters of pills or screws or bolts, different kind of candies, you know. So my son is really happy when I put candies on the conveyor belt.
It's like, reminds me of that episode of I Love Lucy where they're working on the assembly, they're working on the candy production line, and they get backed up, and yeah, exactly. All-time classic.
That was inspiring me to use the conveyor belt.
I love
that Lucy episode. Yes. So let's talk about the pipeline that we need to follow and the stages that we need to follow with Anomaly. So basically we have 4 stages here, and we will talk deeper about those stages. So we have training, we have validation and testing, we have optimization, and we have deployment. Basically, we are using different kind of libraries here. I really want to highlight that we are using PyTorch Lightning for training and testing, and we can use OpenVINO for optimization and also for deployment. So that is really important, because there we can see how OpenVINO, you know, the runtime, the runtime API that we have, is also working with the optimization part that Anomaly has, and also the deployment. Anomaly is working with PyTorch Lightning for training and testing and validation. So we will talk about that deeper later in this presentation. So maybe you are familiar with OpenVINO, maybe no. So I know that we have been talking about OpenVINO for a while, but I really want to make a little introduction about what OpenVINO is. It's really important to understand the foundation of this, and Anomaly is part of the OpenVINO ecosystem. So, and that is the reason why we can see these 2 things together, these 2 libraries together. So we can define that OpenVINO is like a Intel inference framework, but OpenVINO stands for Open Source Visual Inference Neural Network Optimizations. And OpenVINO was born in 2017. So at that moment, I was working just with visual. But over these 5 years, OpenVINO has been growing a lot, and not just for visual, also for NLP, generative AI, audio, LLM. So I think that right now OpenVINO has a lot of things to offer to developers. And also, really, really important is with OpenVINO framework, you can optimize your model and you can deploy the model in different kind of hardware, not just Intel hardware. So, and basically, this is the idea that we have with OpenVINO. So we can use different kind of models coming from different frameworks. We can optimize the performance, we can optimize the model. And with that model, we can deploy in different hardware, different kind of CPUs, as Atom, Core, Xeon. ARM is also supported in the OpenVINO 2023.0. And we have also support for GPU, BPU, and FPGA. So I also want to highlight here that also Intel has a great offer for GPUs. ARC 770, for example, is one of the top GPUs that we have right now, but also we have a lot of offers for edge computers that you can improve the performance of the models at the edge.
Yeah.
So, and also, this is agnostic to the operating system, so we can use Windows, Ubuntu, or Mac. Any questions so far?
What about the Getty?
Oh, this is good. This is a great question. So Intel Getty is a computer vision platform that help different kind of personas to rapidly develop computer vision models. So with Getty, you can train the model with a few images, not tens of thousands of images as usual. So, and we are keeping this pipeline. And I really want to invite the people to, you can put in Google Intel Getty platform, or you can also visit our website. The point with Getty is, with Getty, you can create your models, you can train your models. We have PyTorch, native PyTorch model, but you can also optimize and create OpenVINO and Onyx models in the platform. I really want to talk more about Getty. Maybe in the future, in a show, we can talk about Intel Getty and show how it is also working with OpenVINO.
Yeah, that sounds awesome. Looking forward to it already.
Okay. It's a compromise. Okay, so let's think about how we can start to work with Anomaly and OpenVINO. What is the idea that we have here? And basically, we need to think about, and we want to teach you how we can make this step by step. So basically here you can see the last 4 steps are the 4 steps that we were talking about about Anomaly. But the first 2 are related with the installation of the library and the data acquisition. That is also something that we need to discuss. So I really want to recap something that Samet was mentioning before about the simplicity of the library, because it's really, really simple to use, and it's straightforward for installing. So Samet, if you please can explain how this library is working in the background and how easy it is to install and use the library. That will be super great. It'll be super helpful for developers.
Yeah, sure. Installing the library is as easy as just running pip install Anomalib. That will just install it from PyPy. But for those who would like to install it from source, they could also clone the repo and install it from source. That's possible if they would like to change some of the stuff from the code base. So installation should be straightforward. We usually don't get any installation issues on GitHub. So that just shows how straightforward it is to install. I guess that's about for the installation.
I
Or
really
to
want to
use-
add. I really want to add something. Simon, sorry for the interruption. Is that so
Mhm.
you don't need to be worried about the OpenVINO installation because it's also there.
Yeah.
You can see that it's pip install, Anomaly, and we have full in brackets. And that means that we have a lot of things going with this full. And OpenVINO, the latest version of OpenVINO is there. So we can use the OpenVINO runtime API in the back end of Anomaly. And that is also good because you can also have the benefits to use OpenVINO. Go ahead, Samet.
And obviously OpenCV must be there, otherwise we couldn't run the library in the first place, right? So that's also another thing. As Paula mentioned, Anomalib full is an extra dependency, but if you want to have the full capabilities of the library, this will install everything, like even like the notebooks and stuff, so to run the Jupyter notebook examples in the Anomalib side. And then as well as the OpenVINO and maybe some other external third-party packages for experiment management as well. So like, let's say you want to log your experiments on, let's say, weights and biases or TensorBoard or Comet. So it's all there. Once we do the full installation, it just brings so many functionalities.
That's awesome. I really enjoy it to work with Anomaly. It's straightforward. So, and if you have any issue, I know that installation has no issues for sure, but if you have any issue, also the response that the team has in the issues of GitHub is amazing. So they are working so hard to keep this repository live, and they are so responsible with those activation with developers. And I'm really proud of the team because they are doing a great job with the repository. That is the reason why you have, how many stars do you have right now?
2.k now, but it's going up all the time. So I think we have a linear increase, so that's good.
That's amazing. Okay, now let's continue. So the second step is data acquisition. So in this case, well, we have several options. We have, in this case, so I was working with this Double Magician. So we have the notebooks that you can create the data set using the Double Magician. And this is the first option that we have for this get started process. So the second option is you can download the images. We already have the cubes data set also available in the repositories. So you can download the cubes, but also Anomaly is working with different kind of benchmark data sets. One of those is MVTech that, if we have people here in the audience working with anomaly detection, I would say this is the most common benchmark data set for anomaly detection. But we have more, not Samet? We have more benchmark data sets.
Yeah, so when we first started, we asked this question to ourselves, like, what will be the scope of the library? And for us, it was obvious because we're in an industry, right? So it should be both for research and for industrial use cases, right? So for research, a researcher, when they try Anomaly, they should be able to just run the experiments as quickly as possible. So we should ideally have all the benchmarks that are readily available in the literature. So we have MVTech, we have BeanTech, Collector, Amazon's Visa data set, or we also have a bunch of video anomaly detection benchmarks as well, like UCSD, classical UCSD, Shanghai Tech, Avenue, and all that sort of stuff. So it's basically when the user imports that dataset class, we also do the downloading and preparation of the data as well. So the user doesn't need to care about all this download stuff neither. So it's just everything is sorted by Anomalib. So I think that's also a nice thing to have, because as I said, we struggled a lot when we were working on this problem. So we want people not to have this.
Yes, and normally anomaly detection is happening in different kind of sectors. So manufacturing is one of those, healthcare, security, but you can also try Anomaly by your own. and if you have a specific use case, so you can connect your camera and capture the images or videos coming from your camera or your phone camera. So, we have also that flexibility with the folder option that we have in Anomaly, correct?
Yep. So the folder data set is highly customizable. So we get some feature requests from the community and try to add it there ASAP so that they can train their custom data sets on using Anomaly, because the use cases are endless, and sometimes we cannot just imagine like in what area this could be used, and then sometimes people just show us some use cases. We're like, oh wow, so I never thought that Anomaly could be used in this use case, right? So yeah, I think the folder data sets would be quite useful for the custom data stuff.
Yes. So I think that, just covering the installation, the data acquisition, we can move forward for the next step. That is the first step that we can cover with Anomaly. That is the training part. So as Samet,
one little thing, the UCSD data set, is it the pedestrian data set you're talking about?
Yeah, that's why I said classical UCSD data set. It's quite classical, isn't it?
Well, yeah. It is by Professor, I think, Nuno Vasconcelos group.
Yes.
And
yes, exactly.
Was on my PhD committee.
Nice.
He's technically my advisor from electrical engineering, but it is just
wow.
My advisor was Dr. David Kriegman, who was in computer science. But because I was doing a PhD in electrical engineering, I had to have a electrical advisor, and so that's my connection with. But I never worked on the data set or anything like that. It is just it's nice to bring back memories.
Yeah, nice to hear that story.
So, okay, so I think that, here I want to recap something that Samet mentioned before regarding the unsupervised training that we have. In this case, for training, that we will start this step, we need you to use just normal data. That is, something that we already have in the manufacturing, in healthcare, in security. So, and this is super easy to use. So, so Anomaly has two options. So you can configure the training part. You can configure that with the command line, or also you can set up this with the YAM file, a configuration file. And depending on your use case, so you can use the command line or you can use the file. But basically, we have here a set of managers to create the input for the trainer. And I really want to keep Samet to explain a little bit better how this training part is working with Anomaly.
Yeah, for the training part, as Paula mentioned, so we have a couple of managers, right? And then we try to incorporate both CLI and API users. So because some users just prefer API use, right? So they just use a Python either IDE or Jupyter Notebook and use the API commands. But some other people might just prefer the CLI and then just run it directly, so without bothering with the code base. So we want to have both possible. And we all start with a config manager. So this config manager, it reads from a YAML file, or maybe from if from an API, we just instantiate the classes. But the config manager sorts out and parses the configuration that we need. The configuration for the data, configuration for the model, and for the other stuff like experiment management and other training details. So for the dataset manager, what it does is basically it reads the config and parses the data related stuff. And this data related stuff is just reads the normal data for the training. So we assume that we don't have any abnormal images during training, because, recall the story I was mentioning at the beginning. So we just want to learn the normality without looking at any abnormality, because it can change in the future. So we just need to learn what is normal. So the dataset manager reads the normal data for training, and then the model manager.
Deeply philosophical question, Samet. What is normal?
Right. That's a good question. That is a great question. So I think we could just maybe talk about this in what's next section. But this is kind of, you know, within the anomaly detection field, it's kind of ill-defined. So some people call this like
I'd say
an
it's
unsupervised.
ill-defined in the rest of the world as well.
No, I mean, it's in a sense that like some people call this purely unsupervised learning. And some people say, hey, you know, you always assume that you have normal data. So that means that's, you know, the input data. So you know that it's normal, but it could be polluted as well, right? So it's kind of not unsupervised, but more like a semi-supervised learning. So there's been this debate going on within the literature, and then we still have no clear answer to that, unfortunately. But it's a great question. So
as in life, such as it is in science.
Yeah, right. Yeah, thanks for a great question. For the model manager, yeah, it just parses the configuration. It gets the model. Like, let's say if you want to train a pattern model or an STFPM model or patch score or Efficient80, which is quite recent, it just imports the model. And this is written in Torch and Lightning. And then experiment manager, what it does, this is optional. And if the user sets it, so this could be any third-party apps like TensorBoard or Weights and Biases or Comet or any others. So what it does is basically it logs all the stuff to an experiment manager, whichever they want to log basically, and track the experiment afterwards. So everything is under the hood. So the user doesn't need to add anything else there. And the callback manager, it sets the callbacks. And what is callback? So any sort of, you know, peripherals, we just utilize callbacks, like, you know, when the user, let's say, use loading the weights, or, you know, saving the weights, or timing the training duration and all that stuff. That is not like significantly required, but like it's good to have. So we have those callbacks, like the visualization stuff, you know, saving this and that. So it's all there. And the callback manager sorts out that. And all in all, everything is orchestrated by a trainer object. And this trainer object is by PyTorch Lightning. So we try to be as close to PyTorch Lightning as possible, so that anyone knows about PyTorch Lightning can easily get up to speed with Anomalib as well. And this is really, this really accelerates the, you know, onboarding procedure with Anomalib. And what trainer does is basically it reads this data module models and, you know, the callback stuff, and orchestrates the training. For training, we just do trainer.fit, and it just fits the model and returns us the train model, basically.
So the model manager, it's not a fixed model, right? You could have many different models, or is it a fixed model?
Yeah. No, it's not a fixed model. So the model manager is basically depending on the config. So let's say if the user wants, you know, model A, then they specify that in the config file or in the CLI, and then the model manager returns, you know, the Torch implementation of model A, model B, whatever. Okay. So we have 15. Mm-hmm.
Are these specifically these model architectures? Are they specific for anomaly detection, or you can take any classification model and then turn it into a anomaly detection model?
So the models that we have currently they are all specifically designed for anomaly detection, but technically speaking, it might also be possible to utilize some classification models, but yeah, it might also require some tweaking here and there. But when you look at it under the hood, for these models, you know, they have backbone and the head, and the backbone is pretty much as utilizing an off-the-shelf CNNs or transformers, right. And the head is changing for, which is more specific to anomaly detection problem.
Got it. Right. Okay.
Mm-hmm.
So Samet, I want to ask you something. Maybe I know the answer, but where is happening the OpenVINO connection? You know, because I know that for the configuration, and if I want to have the OpenVINO model, so I need to do something special in the configuration. So
Mhm. So if the user would like to export the model to OpenVINO, in the YAML file, in the configuration, there's an optimization section, and the user can set optimization and export model to OpenVINO. And once the training is done and the validation is complete, the Anomalib automatically exports the model to OpenVINO so that that's ready for inference. And that already accelerates the inference speed. So like the audience can just give it a go to try the difference between a Torch implementation and an OpenVINO implementation on CPU. There's a huge difference.
And
Thank you, Samet.
these models, do they come in different flavors? Let's say, one of the things that I really like about, let's say, YOLO, for example, is that for the same model architecture, they have different sized models, right? Depending on how many layers they are using. So they have a micro, they have a large, extra large, small, medium, etc. And you can choose based on the device you're targeting, right? Do you have something similar in these models?
Yeah, so we have like about 15 plus models in Anomalib now, and almost all of them, yeah, I would say almost all of them, 70+% utilize a backbone, and that backbone is like a ImageNet pre-trained backbone.
Got it.
So to adjust the complexity, usually the papers proposed by the authors, they utilize maybe like a relatively less complex backbones or more complex backbones, depending on how complex their head architecture is. So like, they use either Resna 18 or maybe if they can do it, more complex transformers and stuff.
Thanks.
Okay, so I think that we are clear with the training part. So can we move to testing? Okay, so what is the difference here? So the difference here is that we already include the abnormal images. And I think that also in this case, we are checking the tested model and also measuring the performance with the performance checker. So in details, this testing is using also part of the training pipeline. But in this case, so we are checking the performance, and I think that this is a great approach. It's simple. You can set up the threshold that you want to put in the abnormality. You can set up the threshold, and you can see the performance of your model. So how accurate the model is. So I think that moving forward for the testing part, and it's also important to mention this. Is that we have in Anomaly. I think that this is a great feature that when you are running the trainer, so you can test what is going on. And Samet and his team have been working in create good information with the prediction. In the prediction variable, we have a lot of information. We have the original image. We have the heat map, we have the anomaly map, and we have the predicted mask, and we have the segmentation result. Even if you are, because you can, with Anomaly, you can set up segmentation, classification, and detection. Even if you have the classification, if you are selected classification, at the end also you can identify where the anomaly is using this prediction structure. So I think that this is a great feature, Samet, that you include in the library.
Yeah, I mean, we would like to see what's going on, right? So we would like to have some sort of explainability. So and this prediction object or results object return us everything we need.
Okay, so and moving forward, so the next step is the optimization. And Samet, you already mentioned.
One question I forgot to ask during training is what is the size of the data set that, let's say you start doing a simple object, right? Like the yellow cube, right? Or something simple, right? How many images typically is good enough? Or is it an iterative process that, okay, you start with something and you test, okay, it's not good enough, then you keep adding more images? Is it that kind of iterative process, or are there any guidelines on how many, like a minimum, how many should you expect to get good results?
Depending of the use case, for sure, that depends of the use case. But I can tell you with this example that I create with cubes, that is a really a simple example. I create the model with 5 normal images, just 5 normal images and no abnormal images. And that was working really good. I mean, for one color. Then I was including more colors, five images per color, you know, yellow, blue, red, green, and no abnormal images. In total, I have 20 images. And this is the model that I have right now, working on that robot.
Wow. So for industrial applications where, you know, things are pretty much same, right? You expect things to be very similar, very small number of images could work out, right?
Yes, and also create more like an iterative process. Something is new, if something is changing. So I think that the good point to mention about the data sets is something is changing in the scene. So we need to remake the data set. If you change something, was changing with the light, so you can include that information to the data set, or you need to create a new data set. If you change the camera resolution, so you need, but you know, this is like a more logical stuff that a computer vision developer needs to do, even if it's using another kind of algorithms. But I think that the Anomaly has this advantage that you don't need to use a lot of information to start your model.
Yeah,
I mean,
in fact, this is crucial, and the reason I'm asking this question is, you know, in industrial settings, like I'll give you an example from a project that, you know, 8 years back or so we had received. You know, we were talking to this company, but that never worked out. But the problem was very interesting. These companies were, you know, manufacturing vaccines and those kinds of things in bottles, right? And these bottles, when you ship out, they can break, right? These little, I don't know, they are not bottles, they are ampules or whatever it is called, right? Whatever the vaccines are in. And the thing is that it's not the standard thing, right? They would have different kinds of vaccines, etc. And so it's not like you can train for what is an anomaly, right? It could break, it could have different things. And the samples also change, right? So today they could be doing 3 sets of one kind of vaccine, and tomorrow it will be a completely different product, and they had to do this anomaly detection. So if somebody could do this kind of training in, let's say, 5-10 minutes, right, that was acceptable. But 1 hour and collecting like 100-200 images, that was too much for them, right? But let's say 20 images was okay for them. So in those kinds of industrial applications, where the data changes rapidly, I think this could be perfect.
And this is also good because imagine that in a production line, something new is coming, you know, and you need to retrain the model. I just want to say, you can include a new data set, and the retraining part is also fast. So you can also keep something running in your production system, but also retrain the model and then just push the model again. So, and you could save a lot of cost and loss there. So I don't know, Samet, do you want to add anything else to?
You pretty much covered it, so thanks.
Okay, that's
and
great.
We have 8 minutes, I guess. We might need to speed up a little bit.
So for the optimization part, and here we want to cover the OpenVINO stuff. So Samet already mentioned that we need to set up the configuration to optimize the anomaly model with OpenVINO. In this case, something is happening behind scenes and under the hood is that we can run this optimization. So we can run, OpenVINO has different kind of tools to optimize and quantize the models. So we have model optimizer, but also we have an NCF, that is a neural network compression framework. So with neural network compression framework, we can make post-training quantization, and we can make also quantization aware training. So in that case, so we can move for a full precision to half precision or also integer 8. With that optimized model, we can also use this optimized model for the deployment part and use also the OpenVINO runtime with the OpenVINO model that you already have with Anomaly. Or also, Anomaly has a different kind of functions and has a OpenVINO inferencer that is working also with OpenVINO runtime under the hood. And we can run and deploy the model using OpenVINO. And this, for sure, what is the advantage to use OpenVINO? So the first inference will be faster than Onyx, for example, because Onyx also has this idea to write once, deploy everywhere. So OpenVINO is write once, deploy everywhere. The advantage to use OpenVINO is the first inference will be faster, even faster, and that will keep also the rate inference by inference. So I want to bring an idea about what happened with a padding model, that is an Anomalib model, running in different kind of Intel hardware. So, and this also shows you the capabilities that you have, how you need to manage your production system. So imagine that you have, I don't know, hundreds of cameras and you need to use one machine to process those images and detect abnormalities, run the padding model. So in that case, so you can use the Xeon machine where you can run or have this throughput more than 3,000 frames per second. So that means that you can connect multiple cameras there and run the padding model. So, and these results are using the padding model. But also we have different kind of results. We can also have a flex, a data flex DGPU. That is the DGPU that we use for data centers, where we can also run more than 900 frames per second. And if we talk about the R770, this one, we can also see, and this is a gaming gaming DGPU. And it is good to see how we can switch things in between gaming and AI. So we have here 600 frames per second. And this is also great. But if you are, a hobbyist, and you have a hobby to create some stuff by your own, and you have an M processor, Intel M processor with the Intel developer kit, for example, that is the Intel Celeron N5105, you have 5 frames per second. That is still good. It is something that you are doing, because you want to learn or for educational purposes. So, here we have a picture of what kind of solutions Intel can provide you to work with OpenVINO and Anomaly. So just summarizing the defect detection that we have with Anomaly, we already have this flow, working with the queues, detecting these defects. In this case, we were using padding, but we have more models. And we are also using OpenVINO features, deploying different kind of Intel hardware. You can see and download all the codes that we have regarding this solution in scanning this QR code. And I really want to show you more things about Anomaly, so you can visit the repository that Anomaly has, that is in the OpenVINO Toolkit organization of GitHub and Anomaly repository. But I don't want to keep this just because we were talking about padding and we were talking about that Anomaly has a lot of support and a lot of algorithms. I really want to talk about, or Samet, you can talk about this. We need to keep this short, and sorry for the rushes. But it's good to think that with Anomaly, you have a centralized library where you can use different kind of anomaly detection algorithms. Go ahead, Samet.
Yeah, I'll try to keep it short, but yeah, currently we support loads of unsupervised anomaly detection algorithms. These are like feature embedding based or reconstruction based algorithms, all the way from knowledge distillation based models to memory bank based models or autoencoders of generative adversarial networks. So yeah, as I said, there are like 15 plus models there now, but these are currently on unsupervised based models, but we are also working on some new learning types following the general trend within the field so that we can incorporate zero-shot, few-shot learning-based large vision models. So the team is about to finish an implementation of one zero-shot, few-shot algorithm that's presented in CVPR 22. So I think within a couple of weeks, we're going to be seeing that algorithm implemented there, and then that will be part of the new version.
This is amazing. I did not know there was so much effort that has gone into this this library. It's really amazing. What is your favorite model?
Me or Paula? Paula's is.
I would say.
Paula's.
You say what is my favorite, you know, you say, go ahead. You say what is my favorite.
it's I'm pretty sure Paula's favorite model is Pattern.
I can tell.
Yes.
So, yeah, my favorite model is also Pattern. I like it because it's simple and it works. In terms of generalizability, there are like other algorithms that outperformed Pattern already on benchmarks, like on MVTech or other benchmarks. But when we use them on some other use cases, the generalization capabilities are not that good. But for Pattern, it's simple, fast, and it works. So it's like reliable. So right. I think my favorite one is also Pattern.
So another thing is you need a CPU trainable. So even if you don't have a GPU, you can train the model, and it's super fast. With the 20 images that I have, that was taking like 10 to 20 seconds to train.
Oh, wow.
That was amazing. Yes.
Yeah. That's amazing.
It's super fast. So I think that
pause a little bit for a question, and then we will ask, we give away some goodies to all our audience. And
sure.
For that, we'll ask this question, and then we'll go to audience question. It's okay, if it goes a little bit above after 10.
Yeah, how many slides do y'all have left?
Just 8.
Okay, so we'll pause here. We can go over a little bit. That's fine. Go ahead and do me a favor, unshare your screen here. I'll do our trivia question. We'll go back to the slides.
Okay, go ahead.
Awesome. Thank you. Yeah, so if you're just joining us for the first time, or if you need a little reminder, one of the things we do on this show is give away something to you in the audience. I have created a trivia question based on the slides and presentation from our esteemed guests. And the first person to answer that question in the Zoom chat here on OpenCV Live will win the OpenCV course of their choosing, absolutely free. If you have won in the last couple of months, please do not answer and give someone else a chance to win. Get ready to answer now. I have a feeling this one is going to be very fast. Last time we actually stumped everybody. It took them like a minute and a half. I'm pretty proud of that one. So during the presentation, earlier in the presentation, we were talking about a specific model and brand of robot that Paula used at her demonstration at CVPR. In the chat, tell me, what is the model and name? Say, they got it already. Bruce Wright. Bruce Wright was Johnny on the spot with the Dobot Magician was the name of the robot there.
No trouble. Yeah.
Wow.
Farad was close. Farad was close. Good luck next time, Farad. This time, Bruce Wright. Bruce, please send exactly one email to phil@opencv.org with the course you would like. We will pass that along to the courses team and make sure that you get it.
I wonder if it was an autocorrect. It very well could be. Very well could be.
That's unfortunate. Unlucky.
Yeah, unlucky. Congratulations. Better luck next time, Farad. Onward with the presentation.
Okay. So, 1 second. We are almost done. So, perfect.
Yep.
So, I think that, just for closing and wrapping things, we are working so hard to create this kind of use cases for you, for the audience, for developers. Something that you can replicate easily. This has a lot of value to us, as evangelists, as engineers. We want that you can replicate the work, that you can see that this is useful for you. This is also useful for your work, and you can boost your career also with this. We have these AI reference kits. We have built these real world AI solutions for you. So I invite you to scan this QR code. You can see right now in this website, you can see right now the smart meter scanning with OpenVINO, and also the intelligence queue management with OpenVINO. In 2 weeks, just close to the Intel Innovation Conference, you will see the content of this webinar. So defect detection with Anomaly and OpenVINO. What kind of things you can find there? So you can find the source code, the Jupyter notebooks, videos, and also all articles and papers or white paper that we have for you. And this is a big effort that we have been with, around the globe with the Evangelist team. Just if you are in a region, just please keep in touch with us. Identify who is your evangelist, and if you have any questions, you can connect with him or her and see how we can help you in this developer journey. Please scan this QR code. You can find all of our information there in this QR code. And I also want to invite you. I'm so excited. I'm so excited and also so tired because I'm preparing right now for Intel Innovation. And so Intel Innovation is a conference that we have for developers, for all of you, in San Jose, in the San Jose Convention Center, September 19th and 20th. So please, if you want to go, you can scan this QR code and you can get a discount with this link. I'm really proud of all things that we can show you there. We will have demos, we will have talks, and also we have some experience for you. So Phil, you were asking me about Intel Getty. We will have a super demo there with Intel Getty. You can touch the technology, you can work with Intel Getty, and also you can deploy with my robot there. So
exciting.
Nice.
So this is a risky demo, so I'm crossing my fingers that all will be fine.
It worked at CVPR.
You love those risky demos. I appreciate that about you, Paula.
Yes, no, I love these kind of things. If I am a developer, I really want to see that. So I really want to see that all the things that you can say is working for me. So please scan this QR code and go to San Jose Convention Center. And I really want to say thank you. Thank you for all the organizers, Phil and Satya. As usual, I enjoy a lot the conversation with you, the webinar. And thank you, Samet, also for joining today.
It's my pleasure.
Thank you, both of you.
Yeah,
Really
thank both of you. Yeah, I learned a lot here. Look how professional. They even got disclaimers in there.
Yes, disclaimers and the configuration of the platform that I was using for the benchmark stuff.
Awesome. Yeah, it's great that this actually is functional and like not at 1 frame a second on like the NUCs, for example. That's pretty cool. Like
Are there any audience questions we did not cover?
I think we mostly got them all.
Okay.
Yeah.
If anything else is missing, so you can connect with us through LinkedIn, and we can answer those questions there. More content with Anomaly is coming, so please stay tuned on that, and and follow me, follow Samet on LinkedIn. So we want to share with you more stuff coming in the field.
Yep.
Yeah, and like that repository as well.
That'd be great. So we'll be releasing Anomaly 1.0 next month, hopefully, and yeah, it'll bring so many cool features.
All right. One last announcement before we leave.
Go ahead. Do me a favor and unshare your screen there, and we'll do our little outro.
All right. Yeah. So I have one announcement before we leave. We are doing a 3-hour webinar kind of class, a tutorial kind of class, and it's going to take a long time, but it's a very technical presentation where we will teach you how to do large scale analysis of documents using ChatGPT, and that's on September 17th. It's a Sunday, 9 a.m. So you can sign up there using I don't know whether Phil, do you have that link? It is bigvision.ai/ I think GPT. If you go to my LinkedIn, I'll
grab the link here.
Yeah. So yeah, join us. It is free. You just have to upload a fake resume of yourself so that we can analyze it, and we'll get thousands of resumes so that we can process it. The idea is that there is job description. A large company has there's a job opening in a large company, and obviously thousands of resumes are received for such applications. And most of these resumes are not even relevant. They may not have the right experience, but people like to submit it, just in case. And that's why it's very difficult for the hiring manager to sort through these resumes, and we'll build an automated system that goes through all these resumes and actually matches the job description with the resume automatically. And the challenge there is obviously that this data is all unstructured, right? When you don't have a template for resumes, right? Even simple things like if you say, let's say something like George Washington, right? That could be a road, or it could be a name of a person, right? So you don't know which is the address field and which is the name field, etc. And you have to intelligently parse through it. And fortunately, these things have become so easy these days that we are able to learn everything in about 3 hours, right? And if you don't want to upload that fake resume, the reason I'm calling it fake resume is that we want resumes which are very close, but we don't want your actual name or email address or a physical address or phone number in that resume, because this demo is going to be public, and your resume might show up. You may be the candidate who's selected by the AI algorithm.
Yeah, we don't want that PII anywhere near us. Keep your sensitive personal information to yourself.
That's right. All right, so that's September 17th. Please join if you're interested in that. And then if this thing goes well, we will follow up with something like, how do you take vision applications and combine it with ChatGPT? For example, building, these kinds of resumes right now in PDF format is fine, but a lot of times the PDF may contain JPEG embedded information. So the text is not there, and you have to extract all this text also by training a good OCR model. So, but first, we'll go in steps. If this thing is successful, then we will do the follow-up as well. Right. So that was the announcement from our side. That is, Phil, anything else that you want to mention?
Now let's wrap it up. Well, we've got next webinar, September 21. We've got Anna Kogan back on the show. You and she will be talking about choosing the correct, choosing a good AI contract or a service for your business. So if you're a small business owner or a big business owner, stay tuned for that episode, September 21, same bat time, same bat channel. Steve?
All right. Thank you so much, guys. Thank you, Paula. Thank you, Samet. Really, it was an awesome thing, and I'm very excited to go check out Anomalib myself. We do consulting work, and last time, when we used OpenVINO, it gave us a boost of 2x, 3x. I can't remember, but I remember exactly. We had a model that was performing at 10 frames a second, and we wanted it to perform at 30 frames a second. We just used OpenVINO optimization, and it just, we hit our goal without making any change to the model, right? So that kind of optimization, OpenVINO really helped us, and that's when now it has become part of our standard pipeline. Whenever we want to go and deploy, right before that, we do an OpenVINO pass to optimize, right? And I'm pretty certain that Anomalib will also help us in our consulting work, as it will a lot of other people as well. So I'm going to check it out myself.
Take care of yourselves out there. Take care of somebody else if you can, and have a great day wherever you may be. Thank you so much for watching this episode of the show. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV University, a series of courses and career guidance brought to you by the experts behind OpenCV. Learn more at opencv.org/university.